am Gesicht am besten und da oben brauchen wir eher nicht. Für mich ist es egal, aber wäre es schön, wenn ihr.
Nee, die sind ja
eher alles live.
wäre schon schön, wenn die Leute drauf hören, ne?
Hallo Julia. Okay, perfect. So we would be basically ready to listen to your talk. So basically, the setup is as follows. You are in this kite form, right? I see it as your name. Okay. Yeah, right. So because yeah. So would you mind to? Do you still have time to do the talk? Perfect. So like about what? Okay, so let's do it quickly. Okay, perfect. So would you mind to reconnect? So through the telephone, I hear you. Okay, so wait a second, let's try. So basically we are having a hello? Through the computer, okay, say something.
Can you hear me now?
Yes, okay, perfect, yeah, okay. We can switch from phone. Okay, so basically there is a live stream.
Did I hang up the call?
Yes, okay. So basically, wait a second. Hello, do you still hear me? Okay, perfect. So we have a bunch of crowd here. Maybe you hear them now.
Yeah.
And we can get started soon. So basically, there is one live stream of the. Okay, wait a second. Ah, cool. Okay, so let me show you the crowd. Okay, Chandra. So here's the audience.
Okay.
Okay, so we will get started now. Perfect. I will give an intro of about 5 minutes.
Sure.
And then we can get started. Perfect.
So do I share my screen as a slide or do I just talk about stuff?
So if you share your screen, we will see it. Yeah, exactly.
Okay, great. Sounds good.
Okay, so let me.
How many people are there in the audience?
So we have about, I don't know, about 30, 40 people listening.
Okay, great.
Okay, let me, so basically...
I see some beers in the audience too.
Yeah, exactly, so...
Nice.
Sorry.
No worries.
Okay, so... Yeah, so now you see a little bit what happens here.
Sure.
So, by the way, there is a live stream on Facebook. So let me figure out that I can share the link with you.
Yep.
So you basically can see the video recording. So we have one. Okay. Weiß jemand, wie man das?
Teilen? Klickst du nochmal? Nein, klickst nicht den Link an. Sonst schick ihn noch an. Kannst du nicht haben, die URL oben?
I'll drop the line here. So I sent you a link. If you click it, you should be able to see the live stream, so you see what is happening here.
Did you send me the link over email?
No, via Skype. I can also.
Where do I see that? Okay, here.
Okay.
No. Okay. Yeah, I think I found it. Yeah, got it.
Perfect. Okay. Good.
Oh, it's asking me. One second. Sorry. Copy link. So, should I be on Facebook on this live stream or?
So yeah, Facebook. We are streaming this to Facebook, and let's get started right now. Right.
Okay, great.
Okay, so I'm giving a 5-minute intro or so. Hi, welcome everybody. Welcome to the second Stuttgart.AI meetup in Stuttgart. So we are already having Suryansh from Automata in the call. So it's basically a lot of new faces here, and I wanted to say some words about what Stuttgart.AI is about. So this is so Stuttgart.AI is a global community of people interested, mostly professionals who are interested in the topic of artificial intelligence and in particular the application of artificial intelligence. And we have startups here mostly speaking, and students speaking, and universities listening, and big corporations also. So we are trying to bring that folks together and building a community. Worldwide community means that there are already more than 50 cities around the world who are participating in this Stuttgart.AI format. We are hosting two of them, one here in Stuttgart and one in Cologne. And yeah, today's topic is robotics and also DEEPGRASPING. And so basically this is our agenda for today. Let me this one. Can I put this here? So we had some networking and nice chat, and first we will put on Suryansh. We are a little bit delayed because of some technical problems, and because Suryansh is also very short of time, he has to leave soon. I would directly give him the stage, and he's switched on remotely. You hear him from London. So yeah, let's go. Okay, let's see. Can you share your screen?
Sure. share us on a meeting to make you a presenter. Oh, I think you have to make me a presenter for me to share my screen.
Right, exactly. So how do I do that? Drei Punkten und dann sitzt er.
Yeah, okay, cool. I am the presenter and, alright, cool. So share screen, PowerPoint file. Oh, I can present a specific PowerPoint file, that's cool. 1 second, I should be there in a minute. Yeah, let's see if that goes. That's gonna take forever. Let me just share my screen, that's probably easier.
Guys, you have a nice allocation here.
Do you see the screen?
No, not yet.
Was that a yes or a no?
No.
Yeah, no.
Okay.
Yes? Yes.
You see it now?
Yes.
Perfect.
Great. So I'm gonna start out first of all by saying that although we are a robotics company and we make robots that do physical things, kind of like basically industrial automation. I feel like the word robots needs a bit of qualification these days because literally everything is a robot, including your inbox and your phone and your computer. So we make the classical definition of robot, the industrial robots that do automation on a production line. And I think the definition also needs a bit of qualification in the sense that robots originally started out as the word being assigned to any sort of machine that does work or the robot, so even like a printing press was a robot. But I think modern computing paradigms have redefined that word to mean 3 things. If a machine can sense, perceive, and act autonomously, then it is called a robot these days. Which means it's able to sense what's around it, it's able to perceive it, meaning convert that data into meaning, and then use that meaning to come to a logical conclusion. That's kind of how robots are defined these days. So if we were to take that definition, I don't think we will qualify as a robotics company. And by that definition, we should also not be qualifying for being, or I should not be qualifying for being a speaker in an AI topic. Because our robots are extremely stupid. They don't do any, in the sense that they do what you ask them to do, and they don't have any sensing capability, except maybe that they can sense that they collide with something and stop. But apart from that, they are fairly non-autonomous. So having said that, I will quickly just give you guys a brief presentation of what we do and how we do it, and the kind of opportunities that we saw and the path we took, and in the future what we're going to be doing from here on. So there is definitely an AI ingredient that is going to be a fundamental part of our code in the future, but right now, we as a company, we're called Automata. We started about 3 years ago, and both me and my co-founder Mostafa, from our beginnings in architecture. So we actually worked for this architect called Zaha Hadid. She's quite popular in the architecture landscape at least. She's one of the few architects who's won the Pritzker Prize, which is like the Nobel Prize for architects, so to speak. And you can see why. If you see these buildings, they don't look like buildings. These are not renders, these are real buildings. One of them is in London, the other is in Azerbaijan. And so this office, and in particular, the lady herself, Zaha, she took pride in these kind of homes and kind of created this groundbreaking architecture practice which presented a lot of opportunities for technological research and bringing that kind of research into real life through these kind of buildings. So this is kind of where we got to having me and my co-founder, we were both in the research group in this office. The office was 400 people and the research group was only 4 people. So it was a very, very cool place to work. And we thought to experiment with a lot of kind of technologies and computation methods and design methods and making, using machines to build stuff in all kinds of weird ways. Naturally, the robot was also one of the things that we used, or at least tried to use. So this particular thing, this flower that you see in the middle. This is a 2-floor tall, almost like the size of a 2-floor building. But it's just folded aluminum panels, and they were all basically supposed to be robotically folded to a precise angle and then assembled together. And the dream was, now I don't know if this video is going to stream very well, but do you guys see a video playing, or
Yes.
is it too jerky? Hello?
Nice animation.
Do you see a video, or do you see just still images?
You see an frame animation.
But it's supposed to look gorgeous. That's what we see.
Alright, so basically it was an end-to-end automated process of from conception and kind of creating the basic geometry all the way to producing construction drawings for the robots and the machines to cut and all these kind of things. It was all automated. And I don't know if you see this, but this is robot folding a panel. Do you see that?
Yeah.
So this was the dream, that this is how it would happen. There were like 550 different panels, and each would have been folded individually by robots. In reality, we actually folded 85% of the panels by hand. So this moment became a pretty painful realization that, hey, robots are really not where they should. Like, robots are a good sci-fi fantasy, but in reality, they are pretty far off what people think they are. They're really good at producing cars and maybe producing iPhones or iPads or laptops, because these are all high-volume industries. But if you want to do something cool with robots, like throw them at new use cases and stuff, and automate things that are outside these kind of niche. So with that as a starting point, we thought, hey, maybe we can build a robot that is easier to use. And that was a combination. So being an architect, this is kind of you're taught some amount of engineering, but mostly it's a very creative kind of education. So you have a lot of creative ability and a very limited technical ability. And for both of us, it was a limited technical ability that made us feel like, hey, we can do this. And that was, I would say there was a lot of naivety in that and ignorance, but also a lot of optimism. So we did start a company, and within 2 or 3 months, what you see here in this image, this robotic arm, which is 3D printed, we built this prototype up, and it was working and running and stuff like that. And that convinced us that, hey, this is possible. And it didn't just convince us; it actually allowed us to convince other investors, including one of the world's largest robotic companies, that, hey, this is possible, and that they should fund us. So. And then over time, as we built up this company and as we got funding, we kind of realized that it's not just architects who feel like robots are terrible at what they do. You actually, as we started getting a lot of inbound, we realized that manufacturing kind of ripe for a revolution, because about 90% of manufacturing is still manual. And what I mean by that is when you I don't know if you, can you see a video here of a car being built?
Yeah.
So do you see how many people there are on the factory floor? That was from the 1930s. And this is a video today. This is a Tesla. And there's basically no people on the production line. So the whole thing has become automated, and this is just one industry. So the automotive industry has gone through the sea change transformation over a century, whereas the rest of the manufacturing industry is still like this. These are factories we visited ourselves. This is just like painfully laborious work, which is the same thing in repetitive actions every few seconds. And these are people doing these tasks 8 hours a day. So the reality of manufacturing is really not that many robots. It's actually pretty manual still. So realizing that, and then kind of like going and doing our homework and realizing that it's actually 93% of process in manufacturing is still done manually. We're like, so why is that? And then you go out and you see, okay, so the technology that is actually supposed to do the automation is pretty expensive and pretty complicated to install. And we were coincidentally attacking both of these. We were making a robot arm that was a fraction of the cost, And coming from a design background, this was our niche where we really complicated UI and complicated device and make it extremely simple, very elegant way that programming became extremely simple. So we were simplifying a lot of things in robot, and I believe that it has some real potential. And most of all, when you see this robot, you can see that it was designed by designers. It wasn't like, it doesn't look like a piece of industrial, it looks like a consumer device. And it's designed to work right beside human beings on their desks, which is kind of how we were designing something for ourselves to think through it. So we designed it to be a friendly thing that you can place on your desk next to your laptop and work with it. So this is kind of, this was a snapshot of the company finished our Series A, which is now. This was at seed, like, so this is literally like, this slide would have been true in January this year. That we basically built a robot, built the entire software stack, which we call Choreograph, and having to build a robot out from this cost, we had to invent a new gearbox, which was a low backlash steering mechanism. And we had done all of that with just our seed funding, which was roughly about £1 million. And we've done that in a year and a half with about 10 people. And we had just started taking orders, and we've taken about 50 orders in the first 2 months. And now currently the rest of it is what we are doing. We're scaling up production, we are building our commercial operation, we are doing a number of customer trials. So that's our journey so far. And you can see so in this video, what you'll see is, this is the current state of the art in robotics software. So you can see it is still, this is not Windows 95, it's a Linux-based operating thing completely written for this robot. But this is the market leader right now. And this is still stuck in Windows 95. So you can see we didn't really have to work very hard to do better on software. As compared to this, I would say, what's this? This is how you program our robot. You press a button on the robot and you back drive it, and you can see that the software on the laptop turns red, which means it's observing what the robot is doing. And you show it what to do with a bunch of positions. And then you get a browser-based UI which shows you the positions you recorded in 3D space. I have no idea why it restarted, but yeah, so UI, and you are, I hope there is no lag, because if there is, then what I'm saying is going to make no sense. You basically drive these points onto a linear timeline, and as you do that, you basically tell the robot what sequence to go in, and in which sequence to connect to those points, and voila. It basically then just, you press play, and it runs, and it makes your call. So, moving on, the kind of thing people in, like for example, coffee is good, but it needs to do something more useful. So nearly everybody in the electronics industry does something like this, which is called touchscreen testing, which is if you make your device with a touchscreen, which is practically every electronic device these days, you have to test it to failure. So you have to build a bespoke machine that presses the buttons or touchscreens or opens and closes the hinge of a laptop and stuff like that. And normally that takes engineers about 6 to 8 weeks to design that device. Whereas if you could have a robot, you could just basically reduce your engineering time down to like or the tool at the end of the robot instead of the whole device. So here you go from like a massive time of like several weeks to just a few minutes to have something like this running. Another thing is this, which is basically called, so a lot of manufacturing relies on it, so especially metal manufacturing, because you have to load parts inside a machine, and then you have to tell the machine to start doing its thing, and once the machine is done, you have to take the part out and put it on the tray, and then take the next part, start over. And basically here you have a robot that's capable of picking up 5-10 kilograms, it's picking up half a kilogram. So in a lot of situations, current robots are severely over-engineered, and we can produce a robot which is a fraction of the cost. It doesn't have the same amount of power or the precision, but it's good enough for a lot of things. So here here our robots doing the same thing to a much lighter part. And so there's like, it's similar, like here, this is a real scenario with a tier 1 automotive manufacturer. They produce cameras for cars, and what you can see in this video is it takes a camera and it puts it inside a machine to test, and this machine tests the camera. And you can see loading and unloading the camera inside the machine procedure. And then it has to go onto this other machine and put the sticker and the barcode on the camera and then put it back. And if you simply use a second robot to assist the first robot, which only does the lightweight operation inside, you can basically reduce the cycle time of the operation down from 25 seconds to 16 seconds. So you save 9 seconds per camera. It doesn't sound like a lot, but these guys make 500,000 cameras a week. So if you add the 9 seconds per camera, it adds up to a huge amount. So similarly, there are use cases like this where you don't want to be using people because they are, from a health and safety perspective, not the best human environments to work in. So here is where the pressure to automate is extremely high because people A, don't like working here, and if they do, you have to pay them to be taking these kind of risks. And again, these are tasks which are over-engineered for conventional robots. But it's very easy for a robot like ours to take those kind of things on. So looking at just these kind of 4 use cases that I just showed you, like there's a number of verticals that we can go after, and if you only look at the markets that are easy for us to enter, which are primarily because from a regulatory standpoint, they're very similar to the UK where we are. It's a huge opportunity. So there's only a few startups addressing this, and we are one of the furthest ahead in terms of development. And like you can see at this price point, we're starting to see how 3D printing has exploded in the last 10 years. It broke into many new industries and it transformed many processes. It didn't fulfill the dream of being the consumerized version of 3D printing where people are printing their shoes and foods and clothes and whatever. But it has transformed the engineering industry and the architecture industry and the jewelry design industry and few industries. So through all the inbound that we've got, like we've got over 5,000 inbound leads over the last 3 years, and just mapping where they come from, like manufacturing is actually minority. Like it is still the biggest segment, but it doesn't even make it a half. So there's a lot of new interest that we're seeing, which is kind of a sign to us that something at this price point can really democratize many industries. And this is a little bit of the customer development stuff of how we are doing customer classification into various categories and how do we adjust our sales strategy. But these are some of the people who have ordered robots from us. Some of them are fairly well-known names in their industries. And what we're doing is we have the conventional model, which is like we buy the robot and like a conventional product at £1,000. But then we also have service models where we can use the data from the robots to optimize, to minimize downtime, and to kind of like give you predictive maintenance and things. So to make sure that your operation is running as long as possible. And this is the brief timeline of our evolution and how we've gotten here over the last literally 3 years or so. And in that time, we've attracted a number of investors, and we've also attracted a significant amount of funding. And our teams, we're 2 founders, there's some investors, there's advisors. This team has now grown. This slide is a little bit old. This team is much bigger. There's a lot of technical know-how in the team. We have engineering of all sorts. But we are now hiring again. So we are roughly about 18 people now, and we're probably going to be roughly about 30 people in the next 3 months. So we're growing quite quickly, including hiring some key positions like VP of product and head of talent and things like that. So there's people in the crowd who like London just before Brexit. You're more than welcome to drop me a line. And one of the things that one of the fundamental core innovations that we've had to do has been in the hardware design itself, where we've had to basically re-engineer the low backlash gearbox and find a way of producing it through volume production processes. And in addition to that, like once you do hardware, you also have to spend a lot of time testing it. So this is how we leave. This is the workshop in our office, and there's basically a gym which is running 24/7, which is basically joints of robots lifting weights, thrashing themselves, breaking stuff. And yeah, essentially, so this is kind of what the team distribution looks like. You can see it's a very, very heavily technical team, and over time we're going to be growing the operation and the commercial and also the engineering. Literally everything is, like the whole team is basically going to grow more than double. And we're going to be hiring in literally every aspect of the company. And like talking about the advantages and where we're headed, so you can see in the blue box, one of the things that that we're going to be investing in heavily is sensors and machine learning. So to complete the loop of robot, sense, perceive, and act, machine learning is where it will act or Eva teaches herself. We're going to be investing heavily in sensing, where the robot becomes more aware of its environment and what it's going to be doing. And of course, machine learning, which is like all the data that the robot collects, how we can channel it and what kind of data should it be collecting about itself, and how can we make it easier and faster for the robot, and how can we make it more autonomous or more foolproof or failure-proof, things like that, in addition to the commercial and manufacturing challenges that we have to solve in the next year or so. So just as to wrap it up, this is the kind of transformation that we want to bring to the rest of the 93% of the industry, which is still stuck in the 1930s. That's about the end of my talk. Thank you very much.
Wow.
Oh, sorry. I think there's one last slide, which is this, which is where we are right now, where we're kind of making robotics plug and play for a single operation. Where we want to head in a few years is that we want to grow from being just a single operation robot to a series of robots automating a series of tasks to form an entire production line, and then the robots are basically the dominating computers on the line, where they connect to all the machines on the line. They're kind of like the orchestra conductors, because they tell each machine what to do, because they are the ones taking and removing parts from these machines. So they feed the machines and then they can automate the entire production line. Over time, we kind of want to encompass the logistics side of the operation too, and kind of grow into something like forming an operating system for manufacturing, where similar to what AWS does, where web hosting in the 90s or even 15 years ago was far more complex, and today you just rent space on an Amazon server. You don't care where it is, you just pay a monthly fee and your website's up and running. So we envisage doing something similar to manufacturing, where if you're a producer of something and you want to produce something, you know of market and the technology, you can come to Automata, and Automata can take care of the distribution, logistics, sourcing, and whatever. You just have to rent time on production lines, and you don't care where the production lines are. They could be on a truck, they could be on a ship, they could be centralized or distributed depending on various load capacities and things like that. So we can practically manage all of that for you. So that's where we're headed in the next decade and a half or so. And yeah, sorry, that's about the end. Thank you.
Yeah, Suryansh, thank you very much for this really inspiring talk. Do you see me, hear me?
Yeah.
Yes, I do. I hear you.
Okay, perfect. So my question would be, do you have some time left, like 3 to 5 minutes, to answer some questions from the audience?
Yeah, maybe 5 minutes.
Perfect. Okay. So, anyone has questions? So, yeah, please.
How is it different from KUKA or Tech from Mercedes? What's the unique selling point?
Okay, so the question is, how is this product different from KUKA or Tech Fabric?
Like Daimler.
Like Daimler, yeah.
KUKA or?
Tech Fabric.
Tech Fabric. I don't know who Tech Fabric is, but I know who KUKA is. How is it different from KUKA? Very good question. KUKA is an industrial robot company. KUKA has existed for, I think, 30 or 40 years now. Or no, maybe younger. Sorry, KUKA is actually younger. It's about, I think, somewhere between 20 and 30 years. And they've grown in the automotive industry. And it's kind of similar to, like, we've seen these kind of technology cycles, right? Like, Dell had IBM had its rise and then fall, and Microsoft had its rise and then fall. So when a company develops and it becomes this powerhouse of something, which which is what the current market leaders like KUKA or ABB or Automata are, they entered the market at a time when the automotive production was skyrocketing. They established themselves in that market, and they serve that market exceptionally well. But over time, what's happened is the market has shifted and evolved, and there are now many other industries and many other technologies that are making a lot of new things possible. But these companies have become sort of very good at serving that market, and now it's too risky for them to change into new markets suddenly. So like, for example, we saw that in Nokia and BlackBerry, right? They established themselves in one thing so well that when somebody new and small comes and creates a new thing, it's very hard for these incumbents to suddenly adapt and change to this attitude, or to serve in a new business model, to develop new technology, and to risk your entire product portfolio with a new product that might cannibalize your own products that are doing very well in AI bread and butter. So what we are creating is a robot that can be programmed in 15 minutes. So this is like, to compare our robot one-to-one to a KUKA. If you're familiar with what a mainframe computer used to be in the 80s, there used to be computers that would take a whole room and only a university could buy them. There was no concept of such a computer, even not the 80s, maybe 70s. And then when Atari and Apple and some of these were the first companies to produce a personal computer, they made a lot of compromises. The computer became a lot cheaper and became substantially easier to program because you didn't need a university budget to buy one or to install one. But it took, and over time, over 30 years, it's changed the computing landscape. But if you ask what Apple was doing different from IBM, it was just basically making a very compromised computer at the time. And, or even Atari at the time. Atari failed, Apple succeeded, Apple also nearly died. So what we are doing is similar, where we created a robot which is heavily compromised. It's not powerful, it's not that precise, it's not that heavy, it doesn't take that much power. It just makes certain compromises, but it is insanely easy to program, and it's extremely simple to use as compared to any other industrial robot out there. So it remains to be seen whether this will transform an industry or we will die like so many others, but that's the game.
Yeah, so I think this is really impressive. I like this usability aspect to robots. The robots kind of become closer to the humans, right? By being able, to interact with them so directly. You can touch them and lead them. You work much more closely together with them. So where does you think AI come into this package? So you have shown this timeline of 2 to 15 years. Where does this fit in, and what's the role? What's exactly what is it doing?
I'm going to slightly take the definition of AI slightly loosely, and I'm going to say that AI is data science. It's basically statistical analysis of large amounts of data, and then machine learning and artificial intelligence is a pretty big term. So I think for us, the statistical analysis is already happening. Applying machine learning to it and then kind of making sense of that data is something that we are going to be doing within the next 2 years. For robots to start observing their environments and start taking actions autonomously will probably take another somewhere between 5 to 10 years. So at that point, I would still not call it AI, but I would say it's kind of like how your keyboard on your cell phone starts to auto-complete your words, right? Your sentence. It knows what you're going to say after a word because you've said it 50 times before or 100 times before. It's basically just collecting or observing how you type and making its predictions better based on that. So similarly, Netflix is doing that, and Spotify is doing that. So it's not a huge leap to imagine a robot doing that. I don't know if that should be called artificial intelligence or it's just better prediction. Google has been doing that for many, many years.
Yeah.
So that's quite immediate to us, like within the next year or two. For it to have self-driving car level autonomy is probably much longer, probably a decade or so.
Okay, cool. So, any other questions from the audience? Okay, I think about Suryansh. thank you very much for this really inspiring talk and insight to this company. So basically, if you want to watch the rest of the event, then there is this Facebook link, and we will also put it to YouTube, and I will contact you afterwards anyway. Thank you very much.
Sure. I just wanted to make one last point that if there's audience, if there's people in the audience who are interested in this kind of stuff or applying data science to industrial robots, you're more than welcome to drop me a line. Or if there's anything else about us that interests you guys, feel free to drop me a line.
Yeah, perfect. Okay.
Thank you very much.
We will now carry on with basically the program as we wanted to contact. So, Werner, maybe I talk, so because I have prepared some words before, so like 5 minutes.
Okay.
So we will carry on a little bit. Maybe some introduction that I had to skip, so our speaker can talk. He said he only has half an hour, and then he has to leave. So basically, some words about our City.AI team. This is basically me. I am head of analytics at the company K.I. Analytics, which also belongs to this K.I. group. So you are in the new offices of the K.I. group in Stuttgart, and we are the K.I. group is a company spread around Germany. We have offices in Cologne and in Munich and Stuttgart, and a small office in Berlin. And the K.I. Analytics company is the one that focuses on machine learning. We have some data scientists, and we are also basically hosting these events, one in Stuttgart here and one in Cologne. And also joined and also co-host is Vladimir Han, who is personally not able to attend this time, but we have the third speaker this evening is from his team, and he can tell us something about the work they are doing. Vadim is head of data analytics at Mercedes-Benz Cars at Daimler. Okay, so this is basically the setup here. This is the values. I have already told something about it. So basically, we are AI is all about technology, and what we do is about people connecting you. We want everybody to discover the possibilities of AI. Well, let's call it machine learning or AI, and we want you to have access to tools and knowledge and applying into business. So that's about basically the people who are standing in front, connect their experiences and share them with each other. So that's the idea. And then the topic of today is basically robotics. I wanted to give you a short intro. So basically, humans are already for a long time thinking about mechanical work. So this is a vision from Isaac Asimov, his book I Robot, where he already envisions basically how robots become human-like in a sense and interact with humans. To what kind of problems this leads basically. So also one of our last speaker from Daimler's team will also have to say something on that because so governance is a huge topic in machine learning, I guess. So this is a huge topic. So this is basically a small visualization. So yeah, my wife has a startup where she teaches kids about programming and tries to explain them coding, and this graphics is from one of the it's called Little Bits. It's a small set of microprocessors where kids can attach together components, and it quite well explains how basically robots work, or also machines work, in terms of how humans work. And I wanted to show, because this is something that really also a 5-year-old kid can understand. But it's such an important concept. So basically, it's a very simple process. So you have some sensors on the left. So we humans have sensors on the left, and this feeds data to some processor in the middle, which is a brain. And then following from that, there is some actions that happen. And so basically, what we see here is a semantic view of information, how a human processes it, and a robot is basically a copy of that concept and put into the real world with artificial sensors, with an artificial brain and artificial actuators. So that's basically a robot, and we put it into the world and it tries to. So this is a concept we are explaining. So my wife explains it to kids, and basically it's quite good to understand. And there are for robotics I think two directions, major directions when we talk about robotics. What this is, the one is to use robots to help us in our everyday work. So they will help us with our work, and so we don't need to work as much. And the other one is basically our relationship to robots, right? And then the first talk we have heard is really very nice on the interface, I think, because they are building robots for the left side for basically producing stuff, but with a much better user interface, right? Making things simpler. The second talk we will hear from Werner Kraus. He is from Fraunhofer Institute, and he is coping with deep grasping, and so he will explain us how AI and machine learning algorithms help the robots, and he will give insight how far we are with the technology of making machines intelligent and human-like. So from basically the brain processing part, and this is just one task, basically grasping how hard. Okay, and then. Also, the last talk will be by Timo Gemmecker from Daimler. It's more, well, robotics in finance. So let's see what this brings. Very exciting. Okay, so let's give the stage to Werner at this point.
Habt ihr USB? Habt ihr USB-Anschluss? Habt ihr USB-Anschluss? Der ist ohne Strom geworden. Das funktioniert nicht.
Doch, das hat genug Strom.
Okay, good. Thank you for the introduction, Peter. So, good evening, everyone. I'm not alone today here. Also, two members of my team join me. It's Kilian and Lucas, which are working on the project DEEPGRASPING, which is the topic of my talk. We are in Fraunhofer Institute for Manufacturing, Engineering and Production and Automation (DEEPA), which is located in Stuttgart, so 8 kilometers from here. In the department of robotics, we are around 70 researchers working on all kinds of robots. So robots for household, robots for entertainment, but especially also robots for industrial applications. So Fraunhofer is the third largest institute as IPA in the Fraunhofer Society. We have 2 billion of turnover, over 20,000 employees, if you also count the students working for Fraunhofer. And that's it. Typical forms of cooperation are bidirectional R&D projects with industry. So around 50% of our turnover is done with industry in direct contracts. strategic cooperations with large companies, for example, TOM or other companies in the field of machinery. And then we have also research projects. And just last year, we had also a project with Automata in the field of safety certification. And this was funded by the European Commission. So this is quite a nice collaboration. So we're working together with startups up to large OEMs. Well, but now talk about robotics. IPA works on robotics since 1970s, and this is one of our exhibition milestones in robotics. So we developed more than 150 robot end effectors. And here it becomes clear what's the problem in robotics. That for every application you need a specific robot end effector. So there's no universal robot. You need a robot for different payloads. So from half a kilogram, like an Automata robot, to a robot with a payload of 1.5 tons. So we have here a wide variety in terms of payload, in terms of speed. So the Automata robot works quite closely, for example, with humans. So it makes speed 0.2 meter per second, so quite slow. But we also develop robots which can go up to 10 meters per second. Of course, they are then behind a cage. So there are quite some challenges. Now talking about processes, we have processes like handling, welding, also dispensing, also assembly, which are really complicated because we have to ensure quality for complete automation. And of course, these robots here in the 70s, 80s, basically were the same applications than today, but everything was more or less hard-coded, obviously. And also the sensor technology wasn't available, and today robots become more and more autonomously. And machine learning is on the tipping point to say, for example, in the field of image processing, that we do not learn patterns anymore, but that robots are also able to analyze workpieces, position of workpieces, also identify scenes, so they can detect humans, for example, in their workspace to drive slower. And of course, they can also benefit from something like speed recognition. We have one robot in Saturn, in Ingolstadt, and it works as a consultant, so it waits at the entrance, you can talk to him, and then he guides you to the shelf, because he knows where to find which product. So there's also machine learning in a human-machine interaction. But today, deep grasping is focused on manipulation, and handling applications are quite obvious. So every second industrial robot chip today does handling applications, so it has a gripper for palletizing, depalletizing, sorting. Every fourth robot does welding tasks. So this is half of them is spot welding, which is body in white production, automotive. The other half is path welding, for example, also in SMB production. Assembly is only 10%. So this is, as he said, 93% of all tasks are manual. This is mainly found in assembly, because assembly is really complicated to automate due to tolerances, and also you need really cognitive functions. In our roadmap at IPA, assembly is the next use case then also to use machine learning, because we think that you can make use of these models which we can represent by machine learning. Now, deep grasping, the use case, which we already automated since 15 years now, is bin picking. So it's about grasping vertically stored objects to put them, for example, in the tooling machines on a rack for further welding, for example. And the advantage is you can store the objects arbitrarily in a box. And there's quite a large variety of workpieces, obviously. So this was for driving wheels, gear shafts, for example. So all parts which can be found in an automotive drivetrain as an example. And there are also used typical different sensor principles, for example, one-time measurement, also some laser sensors, or also industrial versions of a Kinect 3D stereo vision camera. So the base is a 3D point cloud, and these objects, these methods are at the moment trained by experts. So you get a CAD model of the object, and then you train it manually. So you say, okay, this is the object. Its pose is in this interval, and you can grasp the object at this and this position. So there's lots of expert knowledge necessary to bring such a system into operation. So here we are not talking about 15 minutes to bring it into operations, partly till it really fits the requirements of a 3-shift production industry. It takes 15 days or even more. So there's really a high need to get the automation into operation quite faster. On the other hand, there were of course also works in research. This is a work done at Google DeepMind together with Berkeley, which is really impressive because now the robot learned to pick objects without any pre-knowledge. The idea is that the robots have this set of parts, articles. They have a 2D camera for visual observing, and so they put together 14 robots so to learn how to grasp these parts within 3 months. And this was one of the largest experiments in this field, and in the end it took 800,000 grasp attempts that the robot learned how to deal with these parts. It was quite interesting because they also learned different grasping strategies. For example, there were also soft articles, and they squeezed, they pinched these objects. So the robot learned really new strategies, like baby, for example. This model, this was also the inspiration for object deep grasping, but we had of course some concerns regarding 800,000 picks, which is not relevant, but not interesting for industry, because they want to have a robot installed within 1 day, maybe 1 week. So our idea was how we can improve the training rate. The logic deep grasping was then defined with the following goals, where we said fast and easy installation of vision-based pick-and-place robots, so that we don't need the experts to bring such a system into operation. And that's exactly also the point which Automata goes. It's, as we call it, the IKEA effect. So you buy a cupboard and you install it by yourself at home, and then you are proud of it because you can install it by yourself. And that's also the way we want to go here. Then we have, of course, also some metrics, something like reliability. So how many % of the grasp are successful, how many do fail. Agility, how long does it take to program a new workpiece, for example in flexible production systems with small lot sizes. And also in the end the performance, so grasp per hour. And that's something where we always compare it to humans, and humans have often an unfair advantage, because when they do perform such a task, they always take 2 arms. Sometimes they take multiple parts on the same time, which a robot normally cannot do. So this is really an important point. And in industrial reality, it's necessary that the robot runs 3 shifts a day, so 24 hours, 7 days a week, to come on the same output than a human in 2 shifts. That's quite typical in warehouse applications. Then we have, of course, automatic learning of workpieces, and we have also some disturbances, like we have parts which have reflections, or also defect articles, or also foreign objects in the bin which do not belong to the bin. Here are some good questions from typical use cases. We said one use case is industrial applications where we have stiff objects. We know a CAD model of this object. It's a typical article which then comes into a tooling machine. where we want to say, okay, we want to tune the parameter automatically. And the second use case is for warehousing. It's a typical depalletizing task, which you can find in the warehouses from Aldi, Lidl, Rewe, and so on. It's a fusion of 2D, 3D data. You have to deal also with this cartonnage in it, also defect articles. And it's also important that the machine learning algorithms are able to identify new objects. So in this area, we will go, is a use case we did not watch yet, but there we will go towards segmentation. So approaches which you also know from autonomous driving, that we use a 2D camera to see, okay, this is an article, and next take the 3D information to plan the actual path. So this is a data approach. Today I will talk more on the use case 1. And for this use case 1, we said, okay, we have not time to grasp 800,000 time. We are doing this in a simulation. So this is a physics simulation which we developed within the last months. So we let a workpiece's weight into the bin, create virtually a point cloud, and on this way we generate label data to train our networks. So this is the basic approach, how we want to improve, decrease the number of real-world experience. And as a first goal, we made a segmentation. So the interest is, what is the workpiece and what is the rest? So rest could be foreign objects, parts of the bin, or also environment. So we developed a binary classificator. There's a CNN working with 6 layers. We created then a patch on the depth map. So basically, we take the point cloud and transform it into a depth map. So it's X, Y, and then C is basically the color. And we get this kind of classification. So here you see some training data, 500,000 runs, 1 image per run, 1,000 patches. And the accuracy worked quite well on the training data, which were all from, the test data, which were all from simulation. And we also applied this now on real-world data. This means a 3D point cloud, which was created from a real sensor with sensor noise, etc. And this is the depth map. This is the prediction. And well, one can see that this segmentation is done quite well. And this will help us to improve our bin picking, the performance. And the next step, as what is ongoing work, is then end-to-end, that we directly estimate the position of the work pieces in the point cloud, which is at the moment an iterative approach. So we are looking in a 6D space for objects, for the object detection, and this is then at the moment our ongoing work. Okay, so that's our insight for the moment. Yeah, we hope. We also had the idea to one day also a meetup in Stuttgart in our labs, which is quite impressive. We have around 70 robots, and there we would also see our demonstrator. Yeah. Okay.
Cool. Then thank you very much for this talk. So we should have the opportunity now to have questions, answer questions from the audience.
I just saw your slide about this project and many robots doing this research. You just mentioned it's Google or is it Berkeley?
It was Google DeepMind together with Berkeley.
Yeah, I maybe saw this video before. I had time to watch in Berkeley teaching the reinforcement learning. And you mentioned how to train this by parallelly licensing these jobs to just generalize these things. And I think there are also some strategy, but as you just mentioned, to train as a simulation. I know some bit of this Moyoku, these things. I'm not sure if you're also using this together with this gym, OBI gym environment. Yeah, it's quite interesting things, and in that videos it's much more advanced. But this really applicable things. I wonder if you have some, your institute has some cooperation with such kind of like company or the university.
Yes, as actually, the project leader from this experiment is Thorsten Krömer, and he was responsible for robotics at Google, and since 1 year he's a professor at KIT in Karlsruhe, and he is also with Fraunhofer IHA. So there we have quite a good link in this area, because it was really interesting what he says, that also Google employees put forward objects into the bin, and the robots learn to craft them also. So it's really funny. Yes.
When you generate the training data with the simulation, maybe you can forward it. At this point, do you even know what the right thing, the right action to pick each single piece is? This is the target, or is it just recognizing the thing?
Yes, so at the moment it's just recognizing object. Yes. So it's just object detection and object pose, also localization. So detect also the 6D pose. So where is the object, in which position and which orientation. There's
now it can be grasped by the robot.
Is then the second step. But it's quite interesting because so we have this approach from Google, which is model free, and there's another approach also from Berkeley, which is then called DexNet, and they intensively use CAD models. They simulate the grasp, so they are looking where can I put my gripper to grip it, and they have I guess more than 1 million point clouds with the gripper. And it's more or less a brute force approach that they go, they look on the point cloud, then they look, okay, where can I put my gripper? And their network charts the success rate, so it estimates the success rate of the grip, and so they can take the best one.
So it's more like a reinforcement approach, like okay, you grasped it or you dropped it? Or
actually, they have it's no reinforcement learning. They have, by supervised learning, are able to train a network to estimate the success rate.
Okay, cool.
But the point where to grasp the object was just also the discussion today with my colleagues, because at the moment it's expert knowledge to determine, okay, how does the gripper look like and where to grasp the actual object.
So from the experiment, is it somehow figuring out by its own what's a good thing to grasp it? Or?
Yes. Well, there are also in research some reinforcement experiments, which are quite funny, because, for example, such a bottle is then connected to a cable, so the robot grasps it, and if it falls down, the cable puts it again in the same position. So they can repeat the experiments thousands of times. But it's really a data problem for robotics. And also Thorsten mentioned, well, sometimes the robot is already broken till you have enough data for your networks.
Do you have any plan to design the end effector based on decision learning?
No, actually not yet. And it's also quite interesting to observe the Amazon Picking Challenge, which was in the last 3 years a challenge where research teams are invited to solve picking tasks. And the gripper was really simple, so it was always a suction cap. And so the winning teams had always simplest gripper. So yeah. For example, also something like 5-finger grippers, which can already be bought. And the bottleneck is really how to program them and how they can really successfully grasp. Because if you have to train, if you have to program the gripper manually, it's a mess. Yes.
So basically, you're using the depth map to do some kind of foreground background segmentation. Is that correct?
Yes.
And so basically, it's a pixel-wise semantic labeling approach, right?
Yes.
So what you normally would do is something like fully convolutional network or some kind of encode or decode structure. I didn't see something like that from what you mentioned. So you said you have like 4 convolution layers and 2 fully connected.
Yes.
How does that relate? So how did you go to, or how do you go to the pixel-wise labeling in the end?
Well, we did this for a patch of pixels.
Okay.
And we are looked for a central pixel. So
okay. And then
basically we looked the environment of 1 pixel.
Okay.
That was.
So you do, okay, basically doing small patches and then like stick them together.
Exactly. Yes. Yeah. Oh, I also forgot to mention. So this work is also together with University of Stuttgart.
Okay.
So it's with EPVS, so Institute for Parallel Verteilte Systeme. Yeah. And that's also a close collaboration. We are also working on this.
Kind of software libraries did you use to learn that stuff? Sort of like TensorFlow cameras or something Fraunhofer specific?
No,
magic
it's just TensorFlow, and the simulation is done in VWeb, which is a physics simulation.
And you started to train the network completely from scratch, or is it some pre-built ImageNet stuff in it?
Which started from scratch.
Okay.
Which is quite interesting because there's also a paper which translates the depth information into an RGB value. So the 3D go to 2D to then also use ImageNet, which is also quite fun. And well, there's also lots of data augmentation to avoid overfitting. So also we squeeze the data, etc. pp. But for further details regarding network, two colleagues are even Okay.
Cool. Thank you very much. Afterwards have the opportunity to talk to him in person. So right now, yeah, let's welcome Timo next on stage. Yeah. Do you need any slides or no?
I would like to do it more in a dialogue kind of way. There's also, I mean, I'm from a big company. We definitely have enough slides already, so I thought I'm just going to talk to you. So my name is Timo, and maybe some of you have a question mark in mind. What is a guy from the finance department doing with robots? And I'm going to clear that up. Maybe a couple of words also why my boss Walid and my department is a co-founder together with Peter of this thing. Because we really believe that any department in a big company should be really good with data nowadays. And that just doesn't matter if you're from procurement, from production, from sales, or from finance. Finance specifically has a problem that we spend lots of time at processing data, manipulating data. It's not the most complex things that we do there. Really downloading data from somewhere, transforming it in another form, uploading it, or making a PPT out of it and sending it somewhere. But it's still dealing with data. So what we said, we need to get really good at that. So we have a department in finance for Mercedes-Benz cars, where we have 3 teams: data science, data engineering, and business analytics. So that's the bridge to the business process. That's what I'm doing, and my 2 colleagues are doing data science and engineering. And then we have information designers and some IT platform and data governance and standards. That's what we do. That's a full-scale analytics department, basically. So what we're doing there, we are mainly doing forecasts and predictions and simulations in finance that we have been doing for years manually in Excel using some advanced tools. And of course we also want to use statistics and machine learning as much as possible to improve things, right? So if we make a better forecast on how much cash we need, then we can get more interest from the bank. That's an immediate effect, and you immediately can see that. So we are not using like deep learning or too much neural networks there. We are still there doing analytics, but we are getting there. So we are already using some machine learning tools, but also some normal statistical tools there, to be very clear. So a little bit about robotics in finance. So we saw the first presentation and then the second one. So what we do in finance is much more close to the first one. Yeah? So that's a robot where we have a problem, a coffee machine, for example, that works manually, and you are really too lazy to do it yourself, right? You just want to save that effort. So you teach the robot how to do that. And in finance, that's exactly the same thing at work. We have thousands of employees in the finance department, only for Mercedes-Benz cars, not even mentioning trucks and the other departments, that every day do lots of manual work. We did the estimation how much percentage is purely manual work, like switching on and off a coffee machine. It's very, very high. So don't give you the numbers, it's scary. But it's normal because our core business is to make really good cars and not to make super good IT systems, right, that help us do our work. But we're getting there now. I mean, if you look at Mercedes recently, you see MBUX, maybe you heard it in the new A-Class, you can actually talk to your car in a more natural way. You can say it's too cold in here, and then the heater will go off. That works now, just coming out, yeah? But it took a while. So now I think we're also getting better at IT systems for our internal process, but we still have to work with the current situation. We are a huge company with many systems, like any other huge company. So how do we get more efficient? How do we get better at that? So it's like patchwork. We use a tool, a robot, but software robots. Yeah. So what we talk about is of course RPA, robotics process automation. Any of you worked with that before? Anybody?
It's a proprietary terminal tool?
No, it's a commonly available software like UiPath, like Blue Prism, Data Load, nice, some different tools. But you can also, of course, code it yourself. It just means that you teach, the same as the first one actually, as Automata, you teach the robot where to click instead of where to move on a computer. Yeah?
We're using this for test automation from platforms.
Yes, very, very common in that, and also from internet, like scrolling data from the web and so on. It's really normal to use that. So in finance, you mainly interact with your SAP system and Excel and PowerPoint, right? But now more modern tools come in. But before we connect all these like source systems where the transactional data comes, and also to do transactional actions in these systems, you really want to, for the not so smart things, you want to teach it to a robot, and then you can invest your brain power, and I mean, most of our employees have great degrees and skills to really make analyses and make some better business plans and better predictions and so on. So the really simple things we want to teach the robot. So it works exactly how the first talk went. You start the recording, and then you show the robot where to click, what to do, and then the robot can do that incredibly fast. And that's much faster than what he showed, because the robot has to actually move. For software, it's instantly nearly. I mean, the response time of the transactional systems is still there, so it's not instant, but it's near instant, because that is actually also really fast. And you can also do it on Excel, so you can transform the data using Excel formulas very quickly as well, and then upload it somewhere else, or send out emails. So I want to give you just a couple of examples that we did. One of them is, for example, to make reconciliation. You have two systems. You have one system here, and you have another system here. And you have the same data in there. You want to check, is it actually correct? Is there any discrepancy? Is there any problem now?
You need three systems. You need three systems.
Why three?
Because you don't know which
one has a problem. I mean, that's the excellent, but sometimes you only have two. And then if you find a mistake, you have to investigate. And you cannot immediately know which one is right, and there's no consensus mechanism between them. It's just two systems sometimes, and so at least the check, if everything is the same, can be performed very quickly, like accounts receivable and general ledger, which basically means two different modules of our financial systems to reconcile them very quickly. That's one thing we did. Another one is to remind our dealers in China how to, what is still open accounts they have to pay or we have to pay to them. To quickly create a list, send it out to hundreds of different dealer groups via email, which takes hours before days of employees just looking it up, copy pasting it to an Excel, sending it out, filling out the email address, sending it out. And that can be done really simple by a robot. And that's live already, that works. Yes. And there's many more. Creating purchase orders or purchase requisitions from preset already. Like you collect some data, what you want to buy, but then the process to actually activate the purchase requisition in the system takes a long time. And it's complicated. So the robot can do that. So we did that, and we started. We used different software at the same time to look which is the best one. And we are currently also in the phase of making it more industrialized and putting it into our shared service centers, one in Berlin, one in Madrid, and then rolling it out more on scale for the whole organization. So we're not there yet. We have a couple of pilots that are running live productively, and now we're looking at that. And until we have all of our IT systems perfectly connected, then we don't need that technology maybe. It will still be some time. So we really think that this software and this approach is very valuable. So then thinking about it, I had a look how much role does it play already in Daimler, these kind of technologies, robotics in total, now not only from finance. I just checked in the job portal before I came here, how many jobs from Daimler have robotics in the title. And it's 12 actually, 12 open jobs currently for robotics in Daimler. So although we are, you mentioned tech fabric, so there's also of course lots of robotics in R&D and in production. But we still have over 2,000 jobs in general, so it's still a long way, and I think that's the whole picture. And yeah, I would be very glad to tell you much more in detail on what other cases we do in finance on data and on analytics. But I think for robotics, this is the main use case currently that we're doing in finance. But we have some ideas already. I used to work in China until 6 weeks ago. Then I came back to Germany, and we started some projects there as well to use NLP to query data. So basically, another big case that happens is not only you have to transform data, but you have to look it up first. And to find it takes a long time. And that robot in the beginning is not smart, right? You have to teach it exactly where to click. And if you don't know where the data is, or which field it is exactly, it's hard to teach to a robot. So we're also looking into NLP, so you ask the robot what's the sales volume last year of the S-Class, and then the robot understands that, translates it to a SQL query, and looks up in the data warehouse and gives you a number out. So that's actually not really hard to do. It's just understanding, translating that to a SQL query, and the rest is really simple because we have, of course, standard like data warehouses and all that stuff in place. So we're looking into how does robotics help a human do their job better. Yeah, this is not related to sales or to other functions as well, where of course we do this as well. So the next step then would be chatbots to interact with our customers or potential customers and so on. And of course there are some out there already. You can try them out, I guess. But yeah, this is the field of what I can tell you today. I'm pretty sure there's many more applications of robotics in Daimler as we are such a big company. But yeah, this is what I want to bring you today.
Thank you very much for this good talk. I will do this. Sure. So yeah, any questions from the audience? It should be.
Do you have a robot for dealing with tax?
With what?
Dealing with my tax?
With your taxes? If your tax is very standardized, which in Germany I'm 100% sure it's not, then maybe.
Yeah, so I have a question. So how exactly does this work? So do you use this RPA system? The input is kind of the pixels on the screen, like a GUI, And then you have some intelligent algorithms, and in the end you have output as clicks of the mouse and movements of
yes. So you record it really exactly the same way. You say start recording, and then you click, and then it records where you click. Some of these systems that we're using have something called computer vision. So they say that they understand where you want to click, and if, for example, then in the real production when the computer runs and the screen is slightly moved to the left or to the right side, then that will understand that that was the button, like the start button on Windows or something like that. It could recognize that. Actually, me personally, I think for this, I want to, if I talk about financial data and this, I'd rather go for the simple version where I just make 100% sure that nothing moves, and I don't want to have some intelligence there in the beginning. Okay. But as these systems also get better and the software gets better, there will be much more intelligence on it, to a point where they have templates already. So they say, if you want to do a cost center report in SAP, no need for recording it because we know how that works. And then you just say, please do it for me, robot. So there's some templates in there. But I think this is still a little bit of a way to go. So currently I prefer the more simple ones where you just tell exactly where to click and then you fix it, and then you have a couple of laptops or on a server and then you monitor it, and then maybe you let it work quickly and you do some sample checks and release it.
Okay.
And how many years are you expecting to just fully automate it?
Well, that's a really good question. Currently this develops really fast. So there's every release of this software really has lots of functions. But because I see this also as a bridge technology, because at the same time the underlying IT systems also get better and are able to communicate much more. If you talk about, for example, not only point-to-point connection, but later on a system where you have microservices and APIs where they talk to each other in a much better way, maybe this will not be needed anymore. But maybe a couple of years until it gets to a point where those templates can be used.
I have a not serious question. You talked about the system you want to integrate into cars, like when you say that it's too warm and it's taking down the temperature, right?
Yeah.
What does the car do when you say there's too much carbon dioxide in the air?
Well, you mean like outside?
Yeah. like an engine that joins.
I have a politically correct answer for that. it finds the next electric car to go for you and pushes it. You had a question as well?
How many jobs do you need if you have the robots in your company?
Yes, perfect question. That's really a big discussion as well, everywhere, and especially in big companies like ours. So we really think that what our employees are doing today is part of this time, yes, can be automated, but actually if you look into the job profiles that I'm hiring currently, it never says you have to copy a lot of stuff from Excel to another Excel and do it in PowerPoint. It actually says you're responsible for the sales process or controlling of the overhead or something like that, and you should analyze it and further develop the process and make better relationship to other departments and customers and all that stuff. And the time that you actually have for doing those things is very limited because you have so much overhead. So I think this enables us to really do the job that we have been hired for 100%. So that's what I think. Of course, profiles will shift as well. We will need much more guys like you, I think, in the future. That's also true. But it does not change that, okay, tomorrow we need much less people. I don't think so. I think we use them much better and give them the tools that they can really focus on that value-added work.
The robots you're training are there. Is it possible to speak about creativity somehow? Because you're just talking about standardized processes. But what you mentioned now, maybe in future times, we can maybe say, okay, if I get hired by a company and it's not just copying Excel files somewhere, there's a level of sense of creativity of things. So maybe in the future or maybe now, in the robotics you're creating, are there any sense of creativity?
In the robot?
Yeah, or in the algorithm.
No. Because like now it is like mathematical.
Yes, this is purely deterministic. So you click here and then the robot will do it, perform certain checks, see if something else moved and then give you a warning signal or something like that. There's no creativity in this.
It's just the exact process to rebuild the exact process.
I mean, as I said, the software in there already has a small piece of intelligence in there where they do computer vision. So they recognize and click on the start button, and then if the start button, maybe there was a new software release and the start button and the cancel button was switched, it will understand, if you enable that function, that it has to click a little bit left. So there is something, but it's also not very good. Computer vision is also purely deterministic. It recognizes some images and then moves the click a little bit.
Just maybe it's a stupid question, but how good is Daimler on data science infrastructure?
Sure, and it's a very good question. I mean, if you look into the whole industry, non-pure tech companies that are like Google, Amazon, Facebook, etc., are all struggling with infrastructure. There was not a single one where I know that the first Hadoop installation was a huge home run. Yeah. So of course this is a topic here as well. But I think in the beginning we started relatively early and made some early mistakes inside as well to learn. And now we're at a point where we really can get somewhere to scale it to a level when the whole company's process and people had to catch up. Yeah, so I think we finished the learning process completely and we're really getting there. And also we're doing this now on a Daimler as a whole level. So it's not only a little department here, a little department there, but we really have a data strategy and have some boards for data governance as well, which is really, really important if you look at the legal implications of having a data lake. It's really critical.
So do you have central AI groups to dealing with all the company related topics?
I mean, Daimler is really big, and therefore I think a central group might always have some struggle. And it's the old discussion, central versus decentral. Of course, there are some experts put in a central department somewhere to start something and to get really high expertise. But we have a more central with a lot of decentral small islands approach. So for example, like my department in finance, we're not the one expertise center for the whole company. We are the one for finance, and then there's a central one in IT. And then there's lots of groups. So we connect those into an AI community, where it doesn't matter where you're from. Sometimes people are hired for another job, but they love to learn that stuff. And then they join this, and then they maybe change their job profile, also happens. So it's a halfly coordinated central approach, I would say.
The point who are especially for financial department. How organizing is your work, like Scrum, like you have an opportunity from department, or you yourself come to the department and you say, we have some feature, we would like to build it, or is another way?
Okay, so the first question, what method we use? Yes, we use Scrum, not the 100% in the book Scrum, but a pretty solid agile method to do it. Really put all the full team that is needed to build something in one room until it's with full time boxing and so on.
How big is it?
I mean, for one project, I would say you need 10 to 12 people, which makes always sense to have a couple of all the different roles that you need: a designer, a business guy who knows the process, and then a data scientist, data engineer, maybe like a general translator between the two worlds. We call them these analytics consultants, and maybe front-end designer, back-end designer, depending what you're building. And the second question on how this works, we don't have a standard process on how we start things, but we have a clear process how to evaluate it. So we look which project is the most valuable. Does it make money? Does it save time? And then we evaluate, and then we do this project or that project.
Homework ideas?
It's different. Sometimes we have an idea centrally. Sometimes some big boss heard it somewhere and brings it in. Can you check that? It's also great when we check it. Sometimes the employee who works in a certain area has an idea and says, I found something in my data, can you have a look at that?
When I think about the standard programs, Ultra IT or Ghost Maps,
These are robots like yours, and these taken or has always the full control of the mouse. And how do you solve the problem that the user can't control the machine when the mouse is already moving, always moving from the program?
Yes.
Can the worker work on another machine, or are the robots fast enough to have the problem?
You mean from the user rights point of view? Or?
Yeah.
Yeah, okay. So this is clear. I mean, therefore we have to have a very strict governance on that and separate it. So you will never give a machine that has a robot on it the full access rights to a system. So you limit it to a task needs to be done there, so if the robot has some problem. And we have, normally the robot pre-prepares a lot and then the user releases it. Because it's the same with autonomous driving today. Yeah, we know we trust our cars a lot, but still from the law point of view, we have to have the hands on the wheel, right? So we do the same here. So they automate something, they run something, and then we do a couple of sample checks, sanity checks, and then we say that's good enough, and then we release it.
But when the robot takes control of the mouse,
yes,
the user can't use it.
Oh, no, that's true. So we have two different scenarios. One is where there's a program on a PC of a user, and there's another one where there's a robot PC, basically. So we have another PC where it's running on a server. This really depends on the use case. If it's a long process, and then you want to automate this one piece, then it makes a lot of sense that the user starts it and then just watches it.
And on another machine?
No, on his own machine, that can be. But also, it can be that this is a complete process, and then we put it on a separate machine and run it. But also this we are still figuring out, to be honest. Yeah, what is the most efficient way to do it? Also, yeah, how to control it the best. All these things are, I think we have a pretty good idea, but everybody's having pilots and finding the best practice. Okay. Thank you.
Cool. Thank you very much. So let's see whether we have something else. Of course, a big thank you to Automata and Fraunhofer and Steinmar, and basically we are KI Group is the host for you, so you are welcome here. Maybe because there was a lot of question, what is this KI Group, and does it have something with künstliche Intelligenz? Some words on the KI Group. No, KI does not stand for künstliche Intelligenz. KI Group is a company that focuses on digital services and consulting for large German corporates, and we have like different branches in 4 locations in Germany, in Stuttgart, Munich, Berlin, and Cologne. And we have about 10 companies that are focusing on different directions. Some of it is blockchain technology. We have KI Decentralized. We have KI Mobility that focuses on business interaction with automotives and also logistics companies. KI KI Finance, KI Retail. We have KI Professionals and KI Connect that are kind of humans resources companies focused on tech. We have KI Labs that are developing applications, and KI Analytics. We are doing machine learning and data science. And so basically the founders are building little small companies. When we go to the companies, we are basically cherry picking the right stuff from each company and specialists and put them together into one team. And that's how we work, and it's like Lego a little bit. Yeah. And this is our new office. So. Okay, I think that's it for today. And we are still here for until. I think we have some more time, like 15-20 minutes we will still have. Okay, thank you very much for listening.